Hello and welcome to another episode of Too Many Projects. Today we're looking at my Marshall TSL 122. In part one I was just replacing the valves. A simple job you might think, but as I set the bias on them I realised there was some thermal drift, and a little bit of googling and learning about the amp tells me that the main board on the first several editions of the amp, they used some sort of material for the circuit board that started to conduct electricity when it got hot or something, which sounds like a design flaw. Anyway, they fixed it for the latter part of the production run, but mine's an early one, and so as it warms up it starts to conduct electricity, shorting out the valves very slightly, which is a bad design, but it seems quite common. So I found this little kit on the internet to fix the problem. We're going to be having a look at that today. This appears to have been manufactured by a company called Dr. Tube in the Netherlands and sold to me by a company in the UK who have assembled it. It's supplied with this circuit board, which is going to be attached to the main board of the amp with a little bit of soldering and a little bit of drilling using this hollow drill bit, which is something I've never seen before, which is pretty cool. And then stuck on with these other bits that are in the kit, which is just some standoffs to keep the circuit board safe inside the unit and steady. So, also supplied was this beautifully produced set of instructions written by the company here in the UK who have assembled it. And we're going to be opening up the amp and going through the instructions step by step to show you how to fix this problem, see if it works at the end. It does give a little bit of a warning on the front of the instructions that it isn't a noob job, this. That you want to have a little bit of experience working with printed circuit boards and are confident with a soldering iron. Both of those things I am, so I feel quite comfortable going into this. But what we're going to be doing is basically drilling out a hole around one of the pins on the circuit board which connects to the valves, then attaching some of the cables from this little breakout board onto those now free pins. I'm connecting another couple of these wires onto the main board, soldering it onto a couple of existing resistors, and then putting this little board with the plastic connectors here in line with the bias adjustment pots and the virtual power reduction switch. I've read them through, it all seems quite simple, so I'll go ahead and grab the amp and get it apart. First thing to do is to get these brand new beautiful valves out that I just put in. Right, and then we'll flip it over and have a look at the other side. Now, this is the main board underneath. It has the clips that hold the valves in place on it, and that's what we're going to be working on, so we need to remove it. And the instructions are nice and clear that you should be very careful about removing this and marking which things go where when you're putting it back together. And also, you should take a picture of it just in case you forget. Oh, there's a lot of them. They have all got labels though, so if I do mess it up, I can rebuild it from a circuit diagram. Connector 2. Three. 5, 8, come on, there we go, you were a tough one, that one's number 13, W9, alright, and there's one more white connector just under the board there which is quite tricky to get to, but I think it connects onto the bias adjustment pot, so I think it's going to come out in one piece. Let's turn it over and see if I'm right. Once I've taken out all, take the main board out the top bit, depending on which way up it is. Oh, I've missed one. Missed two. Possibly three. Okay. There's our main board. That's what we're going to be working on. This is the model number of this board, and the 00 at the end shows that this is the first iteration, and there are some slightly different instructions later, depending on which version of the board you've got. Let's check the instructions, see where we are. So what we're going to be doing is we're going to be working on these connections here, which are the output valve connectors. I've got 7 pins, and we're looking for pin number 5. Pin numbers are written on the connector on the back here, so I can see that pin number 5 for each of these connectors here is the one closest to this edge. That one, that one, that one, that one. I've just pulled this connector off and out the way. We're going to have to put it onto the board somewhere later anyway, but I was just worried I might melt it with the soldering iron. So what we're going to be doing is removing the solder as best we can with the solder sucker from these pins. Then actually we've got the special hollow drill bit that came with the kit, which is going to drill a little hole around it without damaging the pin, and magically therefore make sure the pin isn't touching the circuit board anymore, because that is the problem we've been having. So I think my soldering iron's hot enough now. Let me just give it a quick go. So got to be very careful not to heat the board up much, because there will be some sensitive componentry on here, so just enough to melt the solder and then suck it out. There it is. Hot is good. Perfect. Sort of. Alright, time to get a drill. See if I can fit it in the Dremel and drill out the circuit board around those pins. I'll try and probably get a better camera angle for this as well. So it turns out that the drill bit is not going to fit into the Dremel, it's too big. Just a bit. So this is a hollow drill bit. You can see it's just going to drill a little ring around without damaging the pin. So it'll drill a hole in the PCB without us moving the component. Well, if we drill it, it doesn't matter which way it goes, does it? But, so that's what we're going to do next. Alright, so let's try and drill a hole around that. This scares the living out of me, but it's what the instructions say. So it's a grinding edge here on the drill bit like this, so that is not even slightly central. It's a wobbly drill bit is what it is. No, I think we'll manage. Let's try. So I'm going to try and just be as light with the pressure as I can be. Oh, there you go, I f***ed up already. What am I achieving there? A right mess. This is a bendy drill bit. Well, that isn't a precision tool as far as I'm concerned, but it has generated the desired effect. So next on the instructions is these two capacitors, 36 and 37, and we don't want them anymore. So very neatly I'm going to come in there and as close to the board as possible, cut one off, no capacitors. Next step. So the next bit is to connect this little spider up. So this is the board that's made by Dr. Tube and has come from a UK supplier, but these connections on the left here are yellow and they say V8 and 7. These connections on the right here are red and they say V5 and V6, which conveniently is the label on the board which refers to each valve, and they are just ready to solder straight onto pin 5 that we've released on each of those valve connections. And then the centre two are much more complicated. Now conveniently the instructions that I've got are with very beautifully clear pictures of a DSL. So I think we're looking at this little set of 4 resistors here to begin with, and if you're very careful on the board about how it's been arranged, it says resistor 2, 3, 4 and 5, 2, 3, 4, 5 going across to the right there. The instructions say, and this is really confusing, solder the yellow wire of con 3, so that's the yellow wire from the central section of the breakout board, to the resistor that will be either labelled R2 or R45. Now I'm going to point at R2, which is that one, and it says this is a 100k resistor which has a brown, black, yellow, gold stripe pattern on it. Brown, black, yellow, gold. That looks bang on, so we'll assume it's that one. This is solder the red wire to R3, which is an 82k resistor which has a grey, red, orange, gold stripe pattern. Grey, red, orange, gold. So that seems right. One of them on there, one of them on there. That's really flippin' fiddly. Thanks for that. So we're actually going to try and solder those tiny wires just onto there and onto there without messing it up. This is going to be a test of my soldering skills. Okay, so V5 on the new board. V5 is the valve connector I'm working on. We're just going to solder it onto there. Lovely. That was very easy. The joint is good enough. Move on to the next one. That's number 8. Okay, this is a really tricky piece of soldering. The last bit was really easy. Oh, that's too much. Alright, that one's attached. Kinda where we want it. That's not a neat job. That's not good work. What sort of new hell have I created? Well, it's difficult to see on this lens, but I'm able to sort of zoom in digitally on the camera, and there's nothing. It's terrible. It's really messy, but it works. I've soldered those two cables into the correct resistor on the correct side, I believe. So let's try and mount the little circuit board. So here are these little plastic standoffs. Come with the kit, and they clip into the circuit board here. And then I think if we're lucky, I'm going to put them in before I take the adhesive stuff off. If we're lucky, we'll find that that clips down, goes nicely onto the board in a couple of different places. Let's just do a bit of cable management here. Where are you going? You're going over there. You guys should probably go with that guy. Now, how do we avoid the thing underneath? I think what I'm going to do is I'm going to remove that connector first. Okay, now let's just do it. It fits. So, take those off. A bit more carefully this time. The cables where they need to be. And that's where that's going to live. But we're now going to need to take that board off those standoffs. But Simon, you just put it on them. Yes, well, it was a good plan. Sort of. There we go. And that's back off with the standoffs where they should be. So what happens is, he came out of there, didn't he? Now we're back out. This connector from the board goes into that connector there. So that connector used to be this one, which is the bias adjustment pots on the back. We used to go straight to the main board. Now, instead of that, it comes onto the stable bias board, as it's called. And then this original one goes into there. And so we've now got our original bias adjustment pots affecting the stable bias board, and the stable bias board affecting what happens with biasing the valves individually. And I'm going to try and be a little bit neater with this wiring. Everything is as it should be. Now the fun of reassembly. So we flip this back up, screw it back down, and then see if we can remember where all the connectors went. What a mess. Brilliant. It's like spaghetti. Okay. W9, W10. This does make it much easier. Taking a picture was a very good idea. They look like. Okay, I can't see any connectors on the board with nothing in except the one which used to have the VPR switch in it. I can't see or find any extra loose cables that I've forgotten or missed. I've double checked a little bit against my picture. I think we're ready to go. Let's flip it back over, put some valves back in. And now I will slide it back into the chassis and switch it on. See if it blows up. See if it goes bang. Might do. Might go bang. Okay, moment of truth. Let's try the on switch. Nothing has exploded. This is brilliant. There we go. So that's the left side. So we're adjusting that down to 65. On the other side. We're adjusting. Right, so I'll play a little bit of guitar for a few minutes and then see where it's at in another 5 or 10 minutes. All right then, so another little look, left side. Bear in mind this was about 64.3, 2 or 3, something like that. It's very hard to tell. I think it's come up the tiniest little bit. That's pretty stable. And that side is exactly the same, come up almost exactly the same amount. Let's just do I want to adjust that? Am I just going to make it worse? I don't think I'm going to get any closer than that. So I'm pretty happy with that. I will check the bias once more, but it seems to be super stable now and set up at 65 millivolts. But I'm sadly going to sell that amp I've now perfected. But a good job. Thank you to Dr. Tube for manufacturing that little stable bias board. And to, I forget the name of the company in the UK who have assembled it for us. It does the trick and it's not hard to install, so highly recommended. We'll see you on the next Too Many Projects.